In this video, I am going to show you how to find the zeros, asymptotes, and how to graph this rational function. Our rational function is f of x is equals to 2x minus 4 over x plus 3. To find the zeros of this function, focus on the expression in the numerator. This is because any real number can be a zero of a function, and the expression in the numerator allows that rule. If you were to find the zeros of the denominator, then that value of 0 would make the expression in the denominator equal to 0, and the rational function will be undefined, because anything divided by 0 is undefined. If you don't understand, I can demonstrate you how. So if you were to find the zeros of the denominator, it is x is equals to negative 3. But if you substitute it in all the x variables, in both the numerator and the denominator, you would see that in the denominator, negative 3 plus 3 is 0, and the denominator cannot be equal to 0. Compared to the expression in the numerator, if you substitute negative 3, it will be negative 10, and that is not equal to 0. That's why we only focus on the numerator in finding zeros. The real zero is x is equals to 4 over 2, and you can simplify it to 2. If you were to make 2x minus 4 equal to 0, where you add 4 on both sides and divide by 2, that's how you will find this answer, which can be simplified to 2. So we have our 0. The next is to find the asymptotes. To find the vertical asymptote, that is when we find the 0 of the denominator. And that value, if you were to graph it, is a vertical imaginary line that hyperbolas cannot cross. Our vertical asymptote is negative 3. And that x cannot be equal to negative 3. As I said earlier, if you were to substitute negative 3, it will make the denominator to 0 and it will be undefined. Okay, to find the horizontal asymptote, focus on the polynomial degree of both the numerator and the denominator. We can see here that both the numerator and the denominator have a linear polynomial degree, and the only thing we have to do here is to divide the numbers that are multiplied to x, or so to say, the leading coefficient. So if we divide the leading coefficient of the numerator with the leading coefficient of the denominator, our final answer is the horizontal asymptote will be y is equals to 2. So our horizontal asymptote is y equals to 2. And then we can graph this into the graphing calculator to see the actual graph. This is the graph of the rational function. As you can see here, I have put the vertical and horizontal asymptotes to see that the hyperbolas do not cross both of them. This picture shows the table of the rational function, and you see that there is an error at x is equals to negative 3. The value of negative 3 will make the function undefined, as it will make the expression in the denominator equal to 0, and that anything divided by 0 is undefined. Overall, we have found the zeros, both vertical and horizontal asymptotes, and the graph of this function. In addition, we have found the table set of this function. And our problem is solved.